talk about one of my favorite topics. That is called asset management. Also, life cycle cost, because life cycle cost is not just what you pay to buy a piece of equipment. It's what it costs to own the equipment. You have to operate it, you have to maintain it, you have to buy spare parts for it, you have to fix it when it breaks. So there is a cost of ownership, even if you get a piece of equipment for free. It could be a pump, a pipe, a tank system that's used to make methane gas. Whatever it is, these are all assets, the equipment we use to rely on for fecal management. And so this is cost on this axis, and this is time. And typically, this is the way an asset looks over time. You buy it, you spend a couple years deciding what you want to buy, and you purchase it, and then you actually spend a little bit more time and money to put that piece of equipment into service. And it's a new piece of equipment. It works great. After you get into service, you don't have to pay too much attention to it because it's running well, and people tend to ignore it. But after a little while, since you haven't been paying attention to it, things start to break down, and suddenly you're spending a lot more time on it. You have to put more energy into fixing, repairing. You get some failure, suddenly the pumping system or the valve stops working, and you have to either replace it or figure out a way to make it work. And eventually, everything has a lifetime where it's not going to last forever. But in this curve, your equipment's going to fail, and you're spending a ton of time and money trying to keep it running towards the end of its life. A better way to do it is on this yellow curve. It might be a little hard to see. Same thing, you plan and you buy the piece of equipment, but instead of ignoring it and walking away when it's new, you actually have an instituted regular maintenance program. You do repairs as needed, you lubricate the pumping systems, you check the valves, you replace parts when it's needed, and you just basically spread your maintenance attention more consistently. And what you'll find is that equipment does not break down as much, and it'll last longer, and you're not spending as much money over time. You're actually spending a little bit more money up front to set up this good maintenance program. But the difference between these two lines is the money you save by doing this proactive, very well planned maintenance program. And that's not all. This line that I just showed you is where my utility in Seattle, Washington has been for a number of years. But over the last 5 years, we're doing something even better. We're looking at spending even more money up front, making much better decisions about the kind of equipment that we purchase. We're involving operations and maintenance staff, not just engineers, on picking an equipment or a technology. And when you do that, it costs more money up front. And we're looking at different equipment based on its energy consumption, a lot of different things. So we're spending more time here. And when you do that, and you institute a better maintenance program in terms of not just regular maintenance based on a schedule or a calendar, but maintenance really tailored to what each individual piece of equipment needs. So when you do that, you actually optimize your maintenance needs. You defer maintenance when you don't need to work on stuff, and you get on maintenance right away when you do. And this, again, is not quite where we are as a utility yet, but it's the optimum desire to be. Not just using planned maintenance, but we call it predictive maintenance. You plan better for maintenance, and you use some tools like testing for vibration and other analysis that let you delay and optimize maintenance over time so that it affects the best program possible for your utility. Thank you.
Thank you.